Imagine this. It's 2050, you live in the Northeast, and you walk outside. It's warm. And then you feel it. An Aedes aegypti mosquito bites you in the middle of January. This mosquito historically could not have survived the harsh northeastern winters, but thanks to climate change, they can now. Hello, my name is Lolade Oshin, and I studied how climate change affects mosquitoes through life history traits, the biological characteristics that determine the fitness of organisms. For mosquitoes, these traits directly influence vectorial capacity, or their ability to transmit disease. The traits I measured were pupil development time, initial drive to blood feed, fertility, fecundancy, and longevity. As atmospheric CO2 levels rise, microorganisms consumed by mosquitoes fix carbon at a faster rate than they can assimilate nitrogen. Because carbon fixation is a faster process than nitrogen uptake, the carbon to nitrogen ratio will be disproportionate, with carbon-rich compounds like carbohydrates increasing without the matching rise in nitrogen-rich compounds like proteins. As a result, low-protein environments in mosquito-rearing habitats will form. Nutrients obtained during larval stages will fuel metamorphosis, food hunting, and the development of key systems that influence mosquitoes' life history traits, underscoring the importance of nutrition for vectorial capacity. So, I asked, how will mosquitoes' life history traits be affected by climate change as it decreases the protein content in the microorganisms that mosquitoes consume? To test this, I created 6 environmental groups, low protein and moderate protein diets across 3 temperatures. I reared these mosquitoes and ran 3 assays. A pupil development assay to determine the total pupil development time and time spent pupating, and an initial feeding drive assay that assessed how long it took for a mosquito to locate and feed on blood. I found that both temperature and protein concentration significantly influenced the life history traits examined in the study. Pupae developed at all different rates, confirming that larval environment impacts developmental time. I think this is because the low protein environment did not provide enough energy for mosquitoes to pupate, so they needed more time and food to start the process. Second, low protein environments affected the mosquito's ability to live through and complete emergence. Many mosquitoes were not able to successfully make a transition from pupae to adult mosquitoes. This trend was also seen when there were 7 dead larvae that never pupated. This emphasizes the importance that protein plays in metamorphosis and energy reserves. Third, mosquitoes reared in a low protein environment had a faster drive to blood feed. I think this is because mosquitoes were lacking protein and energy, causing them to have an increased drive to find a blood meal and survive. All in all, having protein available mitigates the effect of cold temperatures and allows mosquitoes to pupate sooner and more uniformly. On the other hand, having a low protein environment delays pupal onset, extends total development time, and decreases successful emergence into adulthood. I predict that as climate change occurs and protein depletes, survival and emergence rates will decline as pupal development times stay consistent. I hope you enjoyed my project. Thank you.